Okay, warm-ups. And by the way, we are starting to get, if you're absent, we can get pretty quick turnaround. Joe was nice enough to, I knew I had someone from the evening that was going to be up in Boise for his job, so he was nice enough to put together a YouTube. It's not all edited and everything, so you're going to have to live with the unedited parts, like what Tim has done a nice job with the editing and so forth on the ones that we have that take a couple of weeks to get on. But you can get the lecture if you need to. If you miss a class, we can do something like this so that you can get the lecture and have that alongside with reading the book. So pretty quick turnaround for you and like I say, the fellow in the evening. So, all right, warm-ups. We're adding fractions, and remember we have to have the common denominator. We've got to have like things to add. So I'm going to convert. I'm going to multiply by 5/5 here and by 3/3 here. So I get 5/15 plus 6/15 for 11/15. Okay. Now, on the mixed numbers, I like to work with them vertically and make them into two small problems. So I have 3 3/4 plus 1 1/6. Now I can work with, remember we went over 6 4ths being that one that, okay, I can work it in 24ths, but the least common denominator is 12ths. So after you've worked it in 24ths a few times, you go, oh yeah, I can do that in 12ths, right? Okay, so I'm going to convert to 12ths. Okay, 3/3 here, 2/2 here for the conversion. So I get 9/12 plus 2/12 is 11/12, and the 3 and the 1 is the 4. So we make it into two smaller problems. Still working with the fraction and the least common denominator, and then we've got the whole number. Well, okay, this next one, we had to carry. Okay, so we got to talk a little bit about carrying here. Okay, 3 2/3. I'm going to convert to 15ths. We've got, let's see, 3/3 here, 5/5 here. So I get 9/15 plus 10/15 is 19/15, the 4 and the 3, 7. And I can't leave it like that because that's neither a proper improper fraction, if you will, nor is it a proper mixed number. Okay, so I've got to take 15 of these 19/15 over here as 1, and I'm going to subtract the 15 here, leaving me 4. So I've got 8 because I had to carry, and the leftover here ends up being 4/15. Okay? Subtraction, same sort of thing. I've got to have a common denominator to subtract. Okay, so if I have 7/8 minus 2/3, we'll convert to 24ths here. And 8/8. So I get 21/24 minus 16/24 for 5/24. The mixed number here, 7 5/6 minus 2 1/4. All right, let's say I forgot that I could do this in 12ths. Okay, I can still work with 24ths. I can work with a common denominator. I'm going to multiply by 4/4 here and 6/6. The clue being the denominator of the other fraction. I can always do that to get a common denominator. It may not be the least common denominator, and in this case, it isn't. Okay, this one, the least common denominator would be 12ths, but we're going to work in 24ths. It's still going to get us there. Okay, 6/24. Okay, so I get 14/24, and 7 minus 2 is 5. Well, I've got to reduce that, so I get 5 7/24. Okay. 7/12. Nobody said any, you let me get away with that. Oh, okay. I reduced the numerator, but I didn't reduce the denominator. The mind went to Cabo. Okay. All right, the last one we have to borrow. Okay, I've got 8 and 2/9 and subtracting 3 1/2. Okay, so I'm going to convert to 18ths. Okay, 2/2 here, 9/9 there, so I get 4/18 minus 9/18. Well, I can't subtract the 9 from the 4. Okay, so I've got to borrow from the 8, making it 7 and 18/18. Well, I'm bringing the 18/18 over here so that now I've got 22 of them. 22/18 minus 9/18 is 13/18. 7 minus 3 is 4. Okay. Okay.
Where did you have to borrow?
Where did I borrow?
Well, I mean, because I got the same answer, but I didn't go about it the way you did it.
Okay. There's other ways of doing it.
I got them all right, but not like that.
Well, and some people like to, if you're one of those that likes to work with your improper fractions, is that how you did it? Working with a big improper fraction on that one?
Yeah, I did 74/9.
Yeah, okay.
And went into the 9
Yeah.
to the 18, 85 or 18, 4, and
Yeah. And you end up with, and let me give you, before we get it, because we've got plenty of time to address that. Let me give you a similar example as to what I did in the lecture here. You know what? No, I'm not going to, because I'm going to get your email address and I'm going to send you the video so that you can see it.
I'm doing it.
Yeah.
I get the
But,
right answers.
yeah,
but
okay.
I'm doing,
You missed the lecture, and you know what? Now that we've got it on video, let me get your email address, and I'll send you the video. Yeah, yeah, we can do that. Gosh, I need to take advantage of that.
It's wrong to do it, though, in the longer format that I'm doing it in.
It's the thing that'll happen, Kelly, is that you can get some awfully big improper fractions. It's not that it's wrong, but when you make it into two smaller problems, you can sometimes have a little bit easier time, perhaps. Your choice. You're certainly not wrong doing that. And if it's something that you've done for a while and you're comfortable doing it and you're getting it right all the time, it's not. But you're going to see an alternative on the lecture, okay? Okay. Today, we are starting in with decimals. And we've got 3 skills for decimals. The first one, we're going to convert a fraction to a decimal. So if I have 3/4, okay, and I want to convert that to a decimal, it's just a division problem. But now we're going to have the decimal show up. So I'm taking 4 into 3. This really, I could write this as 3 divided by 4 that way. Well, when in long division, we write it this way. Well, okay, so 4 into 3 goes 0 times. I better place a decimal, and I've got as many zeros as I need for the division. 4 didn't go into 3, but 4 goes into 30 7 times. And we go out here to 0.75. Now I'm going to address the slang that we use of 0.75 here in a minute when I talk about correct speaking and correct writing, okay, and we're going to do that with decimals. But correctly, that would be 75 hundredths, okay, and we're going to look at that in our writing. It's kind of a hard lecture here. I've got to put the cart before the horse a little bit on this because to really convert fractions to decimals and then decimals to fractions, I really need to speak correctly, okay, and then we're going to talk about writing correctly here in a minute, speaking and writing correctly instead of the slang. So it's not 0.75, it's 75 hundredths. Okay, we're going to remember that. Okay, let's do some more of these. If I have, let's do 2/5. Okay, well that's 5 into 2. And place my decimal, and I've got as many zeros as I need. Okay, 5 doesn't go into 2, but it does go into 20 4 times. So 0.4, also known as 4/10. Okay. Now, 3/8. Okay. 8 into the 3. Again, we have the decimal. And divide out. I've got as many zeros as I need to bring down. And we see we have 3 places on this one. 0.375 or 375 thousandths. With some of these, in fact, you'll have some instructions on your homework to round to the nearest thousandth, because not all of them will. I haven't given you one that goes on and on and on and on yet. Okay, I've given you 3 that have stopped. Well, let's see what happens with some others here. Some of the common ones. Okay, let's take 2/3. Okay, that's 3 into 2. And we get 6. And we're already back at our 2, back with 20 now, because I can bring down those zeros. And that's going to be another 6, and we're going to keep going with 6s. Well, this gets pretty tedious after a while. We have a couple of ways of handling that. If I'm repeating this digit, I can use an ellipsis. I can write it as 0.6 with the 3 dots after it. That means that that digit goes forever. The other way,
What do you call that?
the ellipsis. I think. C-E-S or S, okay. 0.6 with the bar over it, but ellipsis is what I call it. Okay. Yeah, the bar tells me the same thing, that anything underneath the bar goes infinitely. Okay. Well, so let's take a look where we might use the bar a little bit more. If I have 3/11. Okay. Let's do the division, 11 into 3. And we're back to the 3. So this is a 0.27272727 pattern. Okay? And to designate that, I have to put the bar. I can't do this. I can't use the ellipsis on this one, because if I do the ellipsis, if I say 0.27 with the ellipsis, that says the 7 goes forever. It doesn't say anything about the 2. So I can't use an ellipsis with this. I have to use the bar that tells me that it's 0.272727 and so forth.
So if it's only that one number that repeats itself.
If you have one number that repeats itself, you can use the ellipsis or the bar. Let's give you one of those. Let's do 5/6. Okay, 6 into 5. 8. 20. Okay, we got a 3. And now we see that the 20 is going to keep going, and 6 goes into 23 times. So I can use a bar, not over the 8 and the 3, but just the 3. So I can write this as 0.83 with the bar over the 3, or this one I can actually write that way. Okay, so because it is the 3 that continues forever. There's one more that, and that's any fraction with a 7 in the denominator. Let's do 3 sevenths. And I've got a 4. And I've got as many zeros as I need. I've got a 2 there. And I've got an 8 there. And I've got a 5. And I've got a 7. And I've got a 1. And I'm back to 3. When I'm back to where I started. So this one, if I put a bar over those 6 digits, it repeats in that pattern. 0.428571428571428. We tired of that yet? Yeah. Okay, so yeah, the repeating of that pattern. Now, on your homework, you might have something like that, and I might say, give you some directions of round to the nearest thousandth. Well, all right. We look at the, actually, this place value in the 10,000th place, and it's 5 or greater, so we round up. So if I'm rounding this one to the nearest thousandth, like you will in your homework, so pay attention to your instructions on your homework. It would be 0.429, 429 thousandths, okay, to the nearest thousandth. Okay? So yeah, you're going to have some instructions. Okay, so that's converting a fraction to a decimal. Let's go the reverse way from a decimal to a fraction. Okay, so converting from a decimal to a fraction. Okay, if I have 0.25, all right, the slang for that. The King's English says 25 hundredths, doesn't it? I have the 5 in the hundredths place, and I've got 25 of them. 25 hundredths. Well, let's write that out correctly. 25 hundredths. And reduce. Okay, you get 1/4. Okay. We already ran into this one. We saw that we started out with 3/8 and we converted into 0.375. Well, let's go the other direction. So I have 375 thousandths. That's what that says. 375, I'm in the thousandth place. Reduce it, okay? You can certainly reduce by a factor of 5. You can see that you've got a factor of 25. Well, really, you've got a factor of 125 that goes into both the numerator and the denominator. This does reduce, whether you do it in 1 step or 3 steps, to 3/8. Let's take look at 0.06. 6 hundredths. Okay. Okay, reduce it. Now that's different than this, isn't it? That's 6/10. Okay, 6/10. And reduce. One of the challenging things that you get is, for instance, with the repeated ones. okay, you really need to know that that's a 0.33 and a third. We could do that, 0.33, and it ends up being a third, or 33 and a third hundredths. You can get away with doing that way. Okay, so the minute you have to change into your fraction. The 1/3 is the, yeah, okay. And then you can,
A point 103. Oh, then you put it over 100 because it's in the hundreds.
the what?
If you got 0.03 up there,
0.03.
yeah, you don't have it up there.
Okay, 0.03.
So it's over the hundred.
Yeah, so you have
And it's
3 hundredths.
33.3333.
Nope, nope. This one, the repeated 3 from the beginning, is actually 0.33 with a third. And that's about it's one of those things that you really have to know about the pattern in any fashion that you do it, huh?
Is that the same as 0.03? Is it the same as 3?
Mm-mm.
So what do you do when the 3 over 100 repeats itself over and over again?
Well, this one doesn't.
33.33.
This one, the repeating one, I can do as 100 thirds over 100, for instance. And if I look at dividing, okay, I can look at this as 100 thirds divided by 100. Well, that's like 100 thirds times 1 over 100. Those cancel, and that's how you get your 1/3. The best thing to know on these repeating ones is to know that that's 1/3. Just recognize the pattern. Yeah, it really is. Recognize your patterns as that being 1/3, and this one with the repeating one is 2/3. Okay, there's actually, when we get into percentages, okay, later this semester, I give you there's a table in there with 19 of your most common fractions to decimals to percentages, and these two are on it. And there's a couple more that you really should know off the top of your head. Well, 17 more. There's 19 real common ones. But we'll save that to percentages. Okay, correct English on these. And to do that, let's actually take a look at some place values. All right, let's take a look at the units. Okay, that's far enough. Okay, I have units here. Then the decimal. Okay, then I get to tenths and hundredths and thousandths. And this is 10 thousandths place and 100 thousandths and millionths and 10 millionths and 100 millionths and billionths. All right, that's far enough. Notice the THS on the end of all of those. They have the same pattern as when we were going into whole numbers, don't they? The only thing is I start with tenths. I don't have units. Okay? If I went over here and I put a 5 here, okay, this would be the tens place, wouldn't it? So the symmetry is not like many people think about it as being around the decimal, but it's about around the units place. So I have tens here and tenths there. Okay? I don't have any sort of, that we don't do Okay, there's no place for seeing that. We start with tenths, right? Okay. So if I do, we all use the slang. We often say 6.7. I do too. But that's not correct English. If I were to do this in correct English, this would be 6 and 7 tenths. Okay? So I'm actually saying the place value of that last digit, that last decimal part. And I'm saying 6 and, okay, so the decimal here is where we can use that word and. Remember when we had whole numbers, I told you that this is 532. It is not 532. Okay, the only place we use and is for either fractions or decimals, telling us about the part of a whole that we have. Okay, so let's remember that. Okay, so correctly saying those, we have 6 and 7 tenths there. I have 4 and 8 hundredths. Okay, so 4 and 8 hundredths. And we have to have the THS. That indicates that it's a decimal. So I'm going to say how many of those that I've got, and that's, we add that to whatever we have past the whole number part. So let's look at a couple more of these. So this is 5, and I've got 235 something or others, don't I? They're 10 thousandths, not thousandths. Okay, tenths, hundredths, thousandths, 10 thousandths. I've got 235 of them. So I have 5 and 235. Don't forget your dash here. 10 thousandths. I'm going to run out of room here if I don't erase. 10 thousandths. And I have to have the dashes there and there. Okay? That, particularly this one's a biggie, as we're going to find out. Let's look and show you on the biggie. The difference between these two numbers. Now, a little bit about the second one, adding that 0 at the end. This has everything to do with accuracy and significant figures. And you'll probably run into this if you take a chemistry class. This is the first place I ran into significant figures and accuracy in my educational paths. And the fact is that, okay, I measured on one of those scales that could measure out to the nearest thousandth of a gram. I actually measured 7 and 110 thousandths of a gram. That's to the nearest thousandth of a gram, and that's what it came out. So I have to have that 0 because I didn't measure this. Okay, that would say I only measured out to the nearest hundredth of a gram, when in reality I measured out to the nearest thousandth of a gram. And that is a valid value there, it is to the nearest thousandth of a gram. Okay, so I need to write it that way if I've measured it to that. Well, all right, let's take a look at these two numbers here. And I'm going to first say them, and then I'm going to write them. Okay, this one says 7 and 110 thousandths. This one says 7 and 110 thousandths. Now, I gave you a pretty pregnant pause there. But yeah, in speaking correctly, that's a hard one to discern. And let's write them out correctly. The first one says 7 and 110 thousandths. Okay, yeah. There's 100 of them. Okay, what are they? They're 10 thousandths. Now, this one says 7 and 110 thousandths. No dash. I have 110 of those. What are those? Thousandths. So in the structure here, the first one says I have that many of those. Here's my adjective telling me how many of those. There's my noun. For the second one, it tells me I have that many of those. Here's my adjective. Here's my noun. Is that dash important? Yes, it is. This is why sometimes speaking in the slang is a little bit better. The first one I would say 7.0100, and the second one I would say 7.110. Because to speak it correctly, you've got to be real careful. And writing it, you've got to be real careful with the dash. Okay, so you've got some fun ones on your homework to think about that way. So it actually really gets you used to your place values. And remember, that's the 10 thousandths place value out there, and that's the thousandths place value. So be real careful with those. All right, let's do a couple more for working with. If I have 3, this one is 3 and 7 thousandths. Okay, we're out in the thousandths place. Okay, 10 thousandths, 100 thousandths. We have 8,000. $962. Hundred thousandths. So I'm in the 100 thousandths place. How many of them do I have? I have 8,962 of them. Okay. Okay, so that's our first introductory session with decimals. Again, check out your homework. You're going to have some of them like this. Okay, be careful of them. They're a little bit fun to dissect. Okay, they're a little bit of a challenge, but you will get them in these added on zeros do have meaning depending on how accurately you've measured whatever it is you're measuring. Okay, so a little horror story of that with that, and it has meaning to scientists and engineers. And let's just suppose on that one to give you a little bit of a fun thought with, leave you with one for this accuracy and significant figure thing. Let's just suppose, let's look at the difference here. And let's just suppose that you're an engineer for, we'll pick on General Dynamics today. Why not? And you get this contract from the Pentagon, and the contract says that you're to put on your latest whatever bombers they've got a toilet in them someplace, and they got this toilet seat that they say has to be 5.000 pounds. I suspect the general meant this, but I've been, I'm an engineer with General Dynamics, and I don't want to question the general. I've been down that route before, okay, and nope, we don't want to do that. Okay, we can make a toilet seat like this. What it amounts to is between, let's see, 4.9995 to 5. To 5, okay, 5.00049, 9 repeated pounds. We can do that. To the nearest thousandth of a pound, we can make a toilet seat. It's going to mean shaving a few things off and weighing it. Then, oops, I shaved too much off. I'm going to have to put a little more weight onto it. Oops, put a little bit too much weight onto, shave a little more off, and back and forth to get to the nearest thousandth of a pound. This one says between that's easy to do. So this is that notorious $600 toilet seat that showed up somewhere in the Pentagon's budget a few years back. I'm not saying that's what happened, but it could have. Those zeros are important, okay? They say to an engineer, I want to the nearest thousandth of a pound, that toilet seat has to weigh that. Okay, this one gives a fair amount of leeway to the nearest pound. Well, that's not too hard to do. So this one is going to cost you. This one I can pick up at Home Depot. Right? Okay, so that's the difference. So, yeah, these things, these tacked on zeros, you look at them and say, well, I can just chop them off. Well, no, you can't. In my example of this one, I told you I measured that sample of that chemical to the nearest thousandth of a gram. That's a good weight. I'll vouch for that. It's to the thousandth of a gram. It's not to the nearest hundredth of a gram. Okay? So, yeah, that'll give you some little bit of impetus to reading and writing correctly on some of your homework. You really do want to know how to read and write those. They're kind of a little fun to do, you got a couple of them in there to scratch your head over. Okay, so that's it for today. And let's see. Yeah, we've got a couple of the, I've got to get some of the YouTube URLs sent out, so for people that missed it. Now, let's see, Robert, you picked up on it on the evening, didn't you, what we did last? Yeah, okay. If any of you want me to send you any of the video, just so that you can review it, that's available too.